Hello everyone, today we are going to learn a different method to complete a square of a quadratic equation to find its roots, right? Find its root. A different way to complete the square to find the roots of a quadratic equation. So we do a standard completing the square method when we want to find the roots. So we are going to do a complete the square method but in a different way. Okay, let me show you. So first we will find the ABC. We will write down it. The A is 3, B is 4, and the C is 2, right? So there are two to three steps in here that we will do, right? So first step is we will multiply the both sides by 4a. We will multiply the both sides by 4a. Step 1, we will multiply both sides by 4a. What is 4a? 4a is 3, so 4 into 3 is 12, right? 4 into 3 is 12. So we will multiply both sides by 12. For this equation, 4a is 12, right? Okay. So this will be right. 0 will have no effect on it, right? Now, for the second step, we will shift this to the right side of the equation. So it will become a negative, right? Now, for our third step, we will add b square on the both sides. So our third step is add b square on both sides. Now what is b square? Let's find b square. So b is 4, so b square is 16, right? 4 square is 16, right? Now we will add 16 on both sides. So this will just become minus 8, right? When we solve it, minus 12 is plus 16, right? 24, negative 24 plus 16 is 8, negative 8, because negative sign is there. Okay. Now we will see this equation, this set of equation, and we can see that this is nothing but the form of this expanded form of this 6x plus 4 square, because when we solve this we'll get this, right? So we can just write that down here, negative 8. Now this square will go right side of the equation, so it will become as radical, and since this is minus, so now we know that the roots of this equation will be imaginary, right? So we will just put an I here. I is equal to, right? Now this will also go here. So under root 8 can also be written as like this, right? And we can shift this 6 down, right? Now we can find the roots of this equation. So you can solve further to get exact roots, but I'm going to just leave it here, right? Okay. So these are the roots by a different completing the square method, different way to complete the square, right? This is a different way to complete the square and find the roots of a quadratic equation. Now we will take a simple question and we will apply this method to that question, right? Okay. So this is a simple quadratic equation which has real roots. We can find the real roots of this equation by normal Middleton splitting method and by the formula of quadratic equation too. Okay, anyway, so we will try to find the roots by first Middleton splitting, and now after that we will find the roots by a different way to complete the square method. Okay, so first this will become 3x 60x. So one root is -2 and the other root is -3, right? So we can write it here to check it now. Now we will solve this question by completing the square method. Okay. First step is to find a, b, c. Again, normal quadratic equation. A is 1, b is 5, c is 6, right? Now use the steps. Step 1, multiply by 4a on both sides, right? So 4a is equal to 4, just 4. So we will multiply by 4 on both sides. So 4x square plus 20x plus 24 to 0. Then the second step is to shift this guy on the right side of the equation. 4x square 20x is equal to -24, right? Now the third step is to add b square on both sides. So b square is just 25, right? So we will add b square on both sides. This will just be 1, right? 24, this is 25 minus 24, so it will just become 1, right? So now we can complete the square of this equation. This is looking like this: 2x plus 5 whole square, because when we solve this we will get this, right? So I am just writing here that equation: 2x plus 5 whole square. Now let's send the radical over here, right? This will just become 1. Now we will solve further. One time positive, one time negative. So this will equal to -2, and this will equal to -3. We will solve it. So as you can see, our answers are matching. So this means that this method is also right for every quadratic equation. It is not a shortcut method, it is a method that just works, right? And you can prove this method. Actually, you can prove the formula of quadratic equation by this method also. So this is a general form of a quadratic equation. This is a general form of a quadratic equation, right? So we will apply the step 1. What is step 1? We will multiply by 4a on both sides, right? So we will multiply by 4a. So this will be 4a square x square plus 4a bx plus 4ac is equal to 0. Now, second step is to send 4ac on the right side of the equation, right? What is the third step now? Third step is add b square on both sides, right? So we will add b squares on the both sides. Now this is nothing but 2ax plus b whole square. When you will solve this, you will get this. So we can just remove this and write that. Now you can send the roots of b square minus 4ac plus minus, and 2a is equal to negative b plus b square minus 4ac, right? Now you can send the 2a over here, and you can see that this is the quadratic equation formula to find the roots and quadratic equation. You can also derive this formula by this method. What are the steps? You have to first multiply by 4a, then you have to take this equation and put it on the left side of the equation, and now you have to just add b square on the both sides, right? And you have to complete the square, and after that you can derive this, and you can solve many quadratic equations with this method. A different way to complete the square. It is still complete the square method, but in a different way, a different approach to completing the square. Okay, hope you like this video. Thank you for watching.